Okay, so how do we factor this expression? Well, you know, the first step on every factoring problem, you ask yourself, is there anything in common? Like, is there anything they have in common? Like all these terms right here, these three terms, is there anything they have in common? Is there some number that goes into all those? Well, yeah, actually, it looks like, now you could do 2. They're all divisible by 2. But remember, we want to do the greatest. We want to take out the GCF, the greatest common factor. So you want to take out the greatest amount they have in common. They have something bigger than 2. They have 4, huh? They're all divisible by 4. Divide by 4 leaves 7. Divide by 4 leaves 3. Divide by 4 leaves 2. So they have in common. And so what we're going to do, we're going to put the GCF in the front and then the one big parenthesis. Remember how this works. Put the GCF in the front, the greatest amount in common. And then you have the 3 terms on the inside with the pluses between them so that it goes boom, boom, boom. Now, they not only have the number 4 in common, but they also all have x's, don't they? X to the 19th, x to the 12th, x to the 7th. Which one do we take out? The lowest one, because that's what they have in common. They all have 7 x's or more, right? They all have in common x to the 7th. So altogether, the GCF is going to be 4x to the 7th. That is the greatest common factor. That's the greatest amount they have in common. So that's the first step. Take out what they have in common. So let's put that in the front here. 4x to the 7th. Put the one big parenthesis with the 3 terms inside with the pluses between them. And then let's do whatever works. 4x to the 7th times what? Well, that would be the 7. And what power on x does it need? X to the 12th. Because remember, powers add, right? Out front numbers multiply, like 4 times 7 makes 28. And powers add. 7 and 12 goes back to 19. Next one, 4 times, and that's going to be the 3. And x to the what? 7 plus 5 will go back to 12. That good. 4 x to the 7th times 3x to the 5th. That 4 times 3 is 12. Powers add, also be 12. And last one, 4 times, that's going to be 2. And that's it. So all we need is the 2. Kind of move these parentheses over. All we need is 2 there because 4x to the 7th times 2 is 8x to the 7th. Perfect. Okay. And so that is step number 1. Okay. And it turns out we're done. We can't go any further on this. So now, how do I know? Because you might think, well, Mr. Trent, you told us that with 3 terms, we need to go further. Right? And you tell us with 3 terms we need to go further? Yeah, that's true. You need to try to go further, but this one will not go further. Now, how do I know that this one will not go further? Well, it's about those powers. It's about the fact that the powers aren't going to do anything more than that. How do I know they're not going to? Well, how I know is because the powers are usually the 3 terms, the 3 terms inside. Yeah, change my mind. The three terms inside powers are usually x squared, x, and then no x at all, right? But this one is 12, 5, and then no x. So that's just not going to work. They're usually x squared, x, and no x. Or sometimes they're x to the 4th, x squared, no x. That'll work also. But these guys are not going to work. Basically, what you have to have is you have to have some kind of power, and then you have to have half of that amount, and then nothing there. That's the general rule. Now, they're not going to push you really hard. You go to higher, like pre-calculus, more advanced classes, you'll have more advanced. But for now, really just look for x squared, x, and no x. That's, I mean, we might get one that's x to the 4th, x squared, no x, but almost always at this level where we're just getting used to factoring, just look for x squared, x, no x. So if you're doing a problem and the three terms, take out a GCF, and then the three terms inside have x squared, regular x to the first, and then no x at all, then you can do the two parentheses, right? You know what I mean? You can go further and do another step with the two parentheses. And the general rule, it's got to be some kind of power. This would have to be 6. If that was 6 in the middle, this would work. By work, I mean we could do two parentheses on the next step and go further. But it doesn't, right? Because it has to be some kind of power, exactly half that power, and then nothing at the end. But don't worry a lot about that. They're not going to push you really hard. This is just introduction to factoring. They're not, you go to higher classes, pre-calculus and calculus and stuff, they'll push you harder and they'll expect you to know that. But for now, just look for x squared, x, no x. That's what you're going to, whenever you see x squared, x, no x on 3 terms, you're going to do another step where you break them down into 2 parentheses. But we're done right here. This is our answer. And that's the end, because this one will not go further. The powers do not fit the pattern. So we're good. This is a good answer. This just means we stop right here and there's no more work to be done. That's our answer. Just type that in and you'll have it right.